sound. Okay, can everyone hear my sound on the Twitch stream now? It looks like the view meter is working now.
I can't hear anything.
Oh, there's somebody in the Zoom room who can't hear stuff. Matt, could you chat with him and see if you can get that figured out? Alrighty, so going back for a second. My name is Lily Mera. I'm talking about Rust on the front end. Rust has a great type system. It's not just about making stuff that's super fast. We can apply the concepts of Rust to building big front end apps and reap the rewards there. So today we're going to be building this really simple little Pokemon guessing game. You click the button, it loads an image of a Pokemon, and you need to type in the name of the Pokemon to see how good your knowledge is. I'm not very good at this game. This came on recommendation of somebody that I know in the front end space. Can anybody help me out here? Anybody? Well, it's definitely not a Dino guy. Let's cheat a little bit. Okay, so we can see we can get confirmation when we do something right, and we can get rejection when we do something wrong. So let us jump into how we're going to build this app out. Some caveats before we get into the code. This is not an endorsement of any of the technology. All this stuff is very early stage. There's not mass adoption by the browser engines. You are going to run into some compatibility problems at this point, unfortunately. And a lot of this technology is changing pretty rapidly. For example, a lot of the libraries that I'm going to reference have all undergone some pretty major API changes over the past couple years, and it wouldn't surprise me if there was more of that that's coming. So I would not recommend building a startup on any of this software or using it for any mission critical software. However, it's pretty interesting to use it for side projects or things of that nature. There's a couple requirements you'll need. Obviously, you'll need a Rust toolchain installed. You'll need a WASM32 target for your Rust toolchain. And you'll need to install Trunk, which is a Rust tool, command line tool that you can use for compiling, serving, and live reloading your Rust front-end application. And their website, trunkrs.dev, has instructions on how you can get your environment set up, because most of the people using that are using quite similar workflows. Alrighty, so let us jump over to the code and let us get started. So we have here an extremely basic and empty Rust application. Boop. We've got an empty cargo toml with no dependencies. We've got an empty main RS with the everybody's favorite starting hello world program. Let me just pop open a terminal here, which doesn't seem to want to open. There we go. We're actually just going to run a single command this whole time, and that is going to be responsible for managing all the parts of the lifecycle for us. We're going to run trunk serve, which of course is going to fail because trunk uses the index.html file as sort of its root configuration file. So everything that we're going to do is going to be based on whatever is in the index.html file. let me go ahead and open one of those. Index.html. Something else I'd like to say is I really love getting questions. I love being interrupted. So if something that I am saying is not making sense, please feel free to interrupt me.
Your display is blurry.
My display is blurry. Thank you.
Yeah.
Let me see if I can bump up the... How is that looking now? Better?
Slightly. Just slightly. Marginally.
Marginally better. Okay.
Yeah, you're clear on Twitch, but
Okay.
not on Zoom. So I think we might move to Twitch.
Okay, it sounds like it might be an issue with the a different streaming platform.
Yeah, it looks perfect on Twitch.
Cool. So let's fill out this index.html file. We don't have to do anything super fancy in here. We'll have the standard doc type, heading. We'll put a title in there. And that's really all we need to get started. So I think from this point on, we can run trunk serve, and everything from this point on should be live reloaded for us automatically. And so if I were to jump over into my browser at this point and refresh the application, it's now a beautiful empty page. No longer have that guessing game in there. So let us add in a couple of dependencies. The very first one that's going to be the most important for us is the front-end framework that we're using, and this is going to be a framework called Yew. Yew is a front-end framework written in Rust, written for Rust, that was inspired by React, and the more recent versions had a lot of features that are inspired, in fact, by the functional components feature of React. So everything that we're going to do today is very similar to what you might do in a functional components React program with state handlers and the such. So there's a single entry point function that we're going to use. Start app. And the function takes no parameters, but it does take a single type inside of it. We need to tell it what component we want it to render as the body of our application. And so we are going to, let's see. Yeah, that's the error we're getting. So we're going to create that we're going to create that component right now. We'll bring in the Yew prelude, which has a lot of the dependencies we need. We're going to create a function. We're going to call it root, and it's going to return HTML. We can construct that HTML using the HTML procedural macro that comes from Yew. And let's just say, let's put a little hello world message in here. When we're putting literal Rust syntax into this HTML thingy, we need to place it within these curly braces, but largely it works very similar to the JSX syntax that you might use in React. And this is very close to all we need, but there is one extra little thing. We need to add a little procedural macro on this function telling you to take the function and turn it into a component because it needs a little bit of extra machinery. And we'll give it the name of the component that it's going to create. And then at this point, we can pass that type into our start app, the same name as we gave to the component. The name of the function really doesn't actually matter all that much. And at this point, we should have a proper hello world showing up in our browser. Very nice. So we didn't sign up to make a hello world application. We signed up to make a guessing game. So let's start expanding on this. The first thing that we're going to do is we are going to we're going to make a couple of the buttons that we need in order to make this stuff work correctly. So similar to JSX, we need to have a single wrapping element around all of the HTML contents in our components. So inside of our div wrapper, we are going to put just a little button. And this button is going to say get Pokemon in it. And at a certain point in the future, when we click on this button, it is going to perform the web request to load in a Pokemon and download the image data for it. And indeed, if we jump over to the browser, it is showing up, but of course it's not actually going to be doing anything at this point yet. In order to make it do something, we can write some Rust code that will run as a part of the button's onClick handler. Sorry, I'm jumping between a lot of windows. So the way that DOM event handlers work in Yew is you need to wrap a function within a callback, which is a construct that comes from Yew that just wraps Rust functions and turns them into something that can interact with the DOM API. So we create a callback using a closure that takes a single parameter. We don't really care what that parameter is for now. And I'm going to pass it to the onClick attribute of this button. And just like with the text over here, when we pass something as a parameter value using Rust syntax, we need to wrap it in the curly braces. And there's actually a little shortcut that we can do if your parameter name matches your expression name. You can just leave that parameter name off, and this is just syntactic sugar for onClick equals onClick. And eagle-eyed viewers may have noticed that something already changed in our type hinting. When I added onClick as a callback on this button, the type hint changed so that the inner type of callback included mouse event. That is because Yew has strongly typed components, and this button thing actually knows what all of the various callback and handler types it can take in and what kind of events those callbacks all produce. In this case, an onClick event produces a mouse event. So you couldn't, for example, try to read the key code off of this mouse event. You couldn't try to read, I don't know, the time, because it's not a timer fire event. The events are all strongly typed, so it's more difficult to make a mistake with your callbacks, which is very nice. What are we going to put in here? For now, let's just put a little logging message in here. So I want to, console.log some message when a parameter or when our event is fired off. So let's call this mouse event. And then interestingly enough, in Yew core, there's actually not a way to log a message to the console. However, it's relatively easy for us to add that in. We can do this by adding a dependency on the deeper down dependence, the deeper down crate that Yew uses internally called WebSys. And WebSys just has direct bindings from DOM types to Rust, so you can call some of those deeper level browser items. So I'm going to log this mouse event by running WebSys console log1, and log1 is there because Rust does not support variadic arguments, so you can't have a Rust function that sometimes takes one parameter and sometimes takes a million parameters like you can in JavaScript or C or many other languages. So in order to emulate that piece of JavaScript, we instead just have a single function, WebSys console log, that takes an array of items, and then we have a few functions with static arity, so log 0, log 1, log 2, etc. I think maybe up to 5 items, and then you have to start using the array version. But since we only have one thing, we are going to log this mouse event. And this messed with our type hinting, so I'm going to call .into on this, and that's also not enough. So let us statically type that it is a mouse event. All right, now let's jump over to the website itself. We'll reload the page. I will bring up the console, and we can see we're now logging our mouse event. So all from Rust. We haven't written any JavaScript code yet, but we're not going to write any at all today, but we are logging from Rust. We are button clicking from Rust. Neat stuff. Now we actually need to jump from not just logging, but we need to actually make a web request. We need to jump across the network, get an asset, and load it in so we can act on that data. And we're going to need to bring in a couple of dependencies for this. The first one is called request. Request is a HTTP library, high-level HTTP library for Rust. It works on the server side as well as in the browser. It's very full-featured, very easy to use. So it's going to be what we use here. We also need a way that we can run asynchronous tasks because, of course, we're running on the front end. We cannot block rendering. And to do that, we're going to bring in a library called wasm-bind-gen-futures. This is a library that's going to allow us to spawn asynchronous Rust tasks that interact with the JavaScript event loop.
The window is still on the website.
Oh, thank you. I am sorry. Yeah, so we're bringing in a couple new crates. Request, wasm-bind-gen-futures, and finally Saturday JSON, which is what we are going to use for parsing the JSON response from the API that we're using. So that should get us going for a little bit. Let's take a look at how we're going to use those. So as soon as our button is clicked, we log a mouse event. We can go ahead and leave that log in there for now, but in addition to that, we're also going to spawn an asynchronous task that's going to fetch our Pokemon. So let's do that. We can do that with wasm bind gen futures, spawn local, and then we can pass in an async block to this directly. And from within this block, we can run futures, we can hit await, we can do any of the things we would normally do on a server side using a library like Tokyo or async await, or sorry, async standard or small. This is basically the equivalent to, you know, Tokyo spawn, but for the browser. So we are going to hit that API using request. Of course, I don't have the URL memorized, so I'm going to copy paste it. And for now, we're going to hard code the ID of 22. And we're not going to do great error handling on this because we don't have a whole lot of time, but your production Rust applications, of course, should not use unwrap in them. So we're going to make the request, we're going to start to get the response, and then we're going to pull the text out of the response so that we can decode it as JSON. Response.text is going to give us the string of the response body from request, and then we're going to parse that into a JSON value. And we have to import value from start.json. Start.json value is a really interesting type that represents how you can do some kind of dynamic typing using Rust. It's a way that we can represent any valid JSON value with Rust without too many escape hatches in it. And the format of the data that come back from this API, let's take a brief look at it. And of course I don't have a JSON formatter installed in my browser. I thought that I did. That's super. There's a field on here called sprites, and within that sprites field there's a subfield called front default, which has the URL of the artwork that we are going to show up inside of the browser. There's also a top level field called name, and of course that is impossible to find. Excellent. But it's there, you're just gonna have to trust me, and we're gonna use that to compare the user's result against, you know, what the user puts in the text box against what we expect them to have. So we can get the name out of our start.json value using slicing syntax, similar to what you might use on a hash map. This is just going to panic if the key is not there. And in order to turn that from a start.json value into a string, we can use the asStir method, and that returns an option string, and then we can call unwrap on that to panic if the string, if the value is not actually a string. We're going to do a very similar thing with the image source. right, so we have our two attributes now. Let us also log these two so that we can see what we're getting. So we're going to use log2. We'll say name. Alrighty. So we can see there's our mouse event from when we hit the click, and then very quickly thereafter, we have our information. So I guess ID 22 is a Firo, and the image looks like that. So now we have the data, it's loaded into memory. How do we make it show up onto the page? Well, in order to do that, we need to talk about how to manage state in Yew applications. When we're dealing with functional components, Yew has a really cool mechanism that's based on React hooks. It works very well. It's also called the hooks mechanism. So we are going to create a hook that is going to store the state for whatever Pokemon we have loaded into memory. We are going to store that into memory. So the first thing I'm going to do is I'm going to create a struct which is going to store the data about a Pokemon. It's going to have an ID. It's going to have a name. And it's going to have an image source. And we need to have a little bit of helpers on here. We need to derive the partial equal trait on here so that we can compare two Pokemon to each other. This is something that the hook that we're using needs to be able to take advantage of, because it needs to be able to know if the Pokemon that is stored inside of the state has changed, so it can decide if the component needs to be re-rendered or not. So we'll put a derive macro on there for partial EQ. And then the way that we store our state is by calling this function use state EQ, and this is coming from Yew. It's being imported through the preludes, and it takes a single closure, which is used to initialize the value for the first time. And we are going to pass that a none, because there is no Pokemon that's been loaded, and we're going to do some type hinting on that so that it knows it's actually an option Pokemon and not an option integer or something else. And the way this works, it's pretty neat. It has a deref impl, which allows you to get to the inner thing, and then it also provides a method called set, which allows you to change the value that's stored inside of it. Set, which allows you to change the value that's stored inside of it. Set, which allows you to change the value that's stored inside of it. Alrighty, so let us construct a Pokemon down here. Our ID is 22. Our name is a string slice. We need to convert it into an own string, and same with our image source. So we have a Pokemon, and we can now set it as the active Pokemon that's been loaded into memory. And this is not working. That is because when you have a closure in Rust, that closure needs to, or at least this closure does, because of the constraints that are placed on it by Yew, this closure needs to take ownership of all the items that are used inside of it. So we actually need to prepend the move keyword onto this. Wait, what? We need to prepend the move keyword onto this, and we also need to we need to create a new copy of Pokemon state that can be moved into this future down here. Cool. Let's let's print out what's stored inside of our Pokemon state at the time the component is rendered. And we need to pop a debug implementation on this as well so that that will work. Alrighty, going back to the browser. So we can see it starts out as none. We get our mouse event. We log the Pokemon that was loaded, and then this is the component being re-rendered with that Pokemon loaded into our state handle. Ah yes, and this state handle setting should probably be the last thing that happens. It should happen after our log is logged. Let's see if we can get the image to show up now. So I don't necessarily want to just add it to this root component. It's kind of big. There's kind of a lot of stuff that's going on in here already. So I'm actually going to go ahead and create a new component that's just responsible for looking at the Pokemon. So let's call that view Pokemon. And it'll just be empty for now. And this component actually needs to take in some extra properties. It needs to take in a Pokemon maybe, if it's present. So let's see how we can pass properties down into this view Pokemon component. We create a struct that's going to hold all of the properties that we need to pass down into our Pokemon, into our view Pokemon component. And let's put an option Pokemon on there. And then our function component here can take in a view Pokemon props as its input. And we're going to get a compiler error because anything that is used as the properties of a component needs to derive the properties trait. And I believe partial EQ as well. Yes. Properties and partial EQ. Next, now that this is available to us, let's put our view Pokemon component into the root. View Pokemon. View Pokemon equals. Now this is not going to compile for a couple of reasons. The first of which is that we need to be a little bit fancier with how we pull the item out of our use state handle. First, we need to deref the use state handle to get to the inner Pokemon, the inner option Pokemon, and then we need to clone that into a new value, and clone is not currently implemented for Pokemon, so let's derive that. And what's going on here? This is not working because Pokemon state is no longer available to us because we moved it into our onClick handler. So let's copy Pokemon state. And already, it's all compiling now. Success on the build. Our props are not being used though. We're not actually taking that Pokemon that was being passed in and using it to do anything. So let us fix that. The first thing we want to do is we want to try and get that Pokemon out of the props. If it's set, we want to be able to display the image. If it's not set, we want to just return an empty HTML because there's nothing to show. So let us do that. We'll do that using a match. Match with an early return in it, and that will give us a Pokemon that will definitely be present. Now we can take this and turn it into some HTML that has our lovely image inside of it. This is not going to work because we can't move out of the borrowed Pokemon prop, so let's borrow it. And there we go. We are displaying an image, in theory. Let's see if it works. Jumping over to the browser, we'll refresh the page, hit that Get Pokemon button, and yeah, there it is. There is our Fearow. We're not guessing it yet, but it is showing up. So we're one step closer. We've covered a lot of content so far. Anybody want to jump in with any questions before we continue? Okay, that's fine too. Let's keep it moving. So the next thing we want to do is we want to be able to present the user with a way to enter a guess. We want to give the user a little text box that they can use to type in a guess, as well as a submit button that they can use to check that guess. So let's build that out. Have an input type equals test, and let's also make button close it. Alrighty, so we've got a text box, we have a submit button. They're not connected to anything yet, but they will show up when we have a Pokemon. And let's see if we can get those wired up to each other at this point. The first thing we're going to do is give our button an onClick handler. And we're going to use the same similar method that we used before. We're going to create a callback. And we're going to pass it into the button. Mouse event. And if you think about what we need to do in here, we have a Pokemon. The Pokemon has a name. We need to check what is inside of the input element and compare it with the name of the Pokemon that we're expecting. So if anybody has worked with React before, can anybody hazard a guess as to what type of construct we might use to pull out of this input? very similar to how you pull things out of input elements in React, I think.
On change handler?
On change handler, that's a possibility. It's a little more a little more complex than what we want to do here, I think. We're actually going to use a ref. So a ref is a way that you can basically bind a variable to an element and then access that element at a later time in an event handler, like this, for example. The way that works in Yew, we create an empty node ref using node ref default, and then you pass it as the ref property of any element, just like that. And now we should be able to read the input value of this this input box from our callback. So let's try and do that. Now it's a node ref. It's not a input ref, or it's a generic node ref. So it could refer to an input box. It could refer to a button. It could refer to an image. There's a question in the Twitch chat. Is the unmanaged form approach the default or suggested way to do things in the Yew library? That is a good question. I am not a front-end architect, and I can't really speak to what the correct way to do these kinds of things are. This is certainly a way that you can do things. There are a lot of there are a lot of higher level libraries that can be used for managing forms. This is kind of just the down and dirty way that I could fit into an hour. But there's a lot of other people who are doing harder work in this space who probably have some better answers than me on that. Anyways, a node ref could refer to any HTML element. So because Yew is statically typed, we actually need to tell it, hey, this node ref actually refers to an input element specifically, so that we can access the properties that are specific to an input element. So we're going to do that by calling the cast method on it and giving it a type hint to HTML input element. That's going to give us an option which we can unwrap, and I need to import that element name from WebSys. And we're having some move errors. So let's move that input ref into the closure. And make sure we clone before it's moved. So we have an HTML input element. Let's pull the guess out of it. Say input.value dot to lowercase to normalize, and then we have the string that was entered into that element. Let's print that string out for now. Alrighty, we wrote a bunch of code. Let's try it out and make sure that it's working the way we expect. So we'll load our Pokemon. This layout isn't very nice, but let's see. If I enter hello and hit the submit button, there is hello in the console. And we can see that our lower casing is working as well. Next, we actually need to compare the guess that was entered by the user to the name that we're expecting to see based on what was on the Pokemon. So let's jump back over into the code. Let's pull the name off of our Pokemon. And let's compare it with the guess. Now, if the guess is equal to the name, we need to do something. And if it's not equal to the name, we need to do something else. What is that something? Well, we actually need an extra piece of managed state in order to handle that. But what kind of state are we going to use? We're actually going to create another custom type for this. We're going to create an enum this time called guess, and it's going to store correct or incorrect. And once again, we're going to put some derives on here. Partially Q, debug, clone. So first off, there's not going to be any guess, but then we are going to have an option guess. And at some point, we're going to store a guess in here. So if the guess was equal to the name, we're going to store that we stored a correct guess. And if it was wrong, we're going to report that we stored an incorrect guess. The state dot set and we're going to store the correct or incorrect status of that guess based on how these two things compare. And we also need to render our guessed state into the DOM somehow. We can do that in a real quick and easy way by just printing out the debug representation. And we are, of course, going to have to clone this because it's getting moved into our onClick handler. Alrighty, let's see if our guess checker is checking the guess. So it starts out holding none because there's no guess that's been made by the user yet. Is it a bird thing? No, that's incorrect. Is it a Furo? Yes, that is a Furo, so we have a correct guess now. Let's actually make something that knows how to display this guess in a much more nice way. We're going to once again create a new component with its own props that can handle the guess. Function component, view guess. Return HTML, and for now, we can put this in there. It's going to be on the props. The props are going to be view guess props, option guess, whoops, that's not what I meant to write. And we're going to derive properties and partial EQ for our property types. Then let's drop this into our DOM. View guess. Guess equals just like the view Pokemon. Oh, I'm very sorry to everyone watching. I'm being very bad at switching between the editor and the browser, and I apologize. Okay. We have our view guess component. It has properties, and it is being rendered from the view Pokemon component. It's very similar to the view Pokemon component, or at least what the view Pokemon component looked like in the beginning, but it is yeah, we're going to make it a little bit nicer now. So similar to the Pokemon component, we need to unwrap our guess. We need to return an empty HTML object if there's no guess that was present, and we need to return something that tells the user good job guessing or bad job guessing, depending on what they guessed. So let's make a little matcher that can do that. We'll early return. And actually, let's not do this. Let's make some text inside of this matcher. We'll say, yes, you did it. And if the guess was incorrect, we'll say no, that's wrong. You did a bad guess. And we'll show that to the user inside of a div. Jumping back to the app. Of course, we know it's a Firo now. Yes, we did it. What if I thought it was a Firo 2? No, that's wrong. Sorry. Bad job. There's one other main piece to this, and that is randomness. So obviously a guessing game where you get the exact same thing every time is pretty boring. You're gonna get pretty good at typing Firo. So we need to inject some randomness into our application. And we actually need to include an additional dependency in order to do that. So in our cargo toml, we'll add a new dependency on rand. I think that's the latest, yes. We'll add our dependency on rand. And up here in the code where we are generating our request, we want to randomly generate an ID. So that's going to be a number between 1 and 100. The thread RNG function is a function from rand that returns a thread local random number generator. And on RNG, we should be able to call a method to grab a random number. 2. We need to import a trait for that, the RNG trait. And we are running into a compiler error because we actually have to configure something in order for this to work with browsers that I forgot about. A transitive dependency of the rand crate get random requires this special little feature flag JS in order to work properly within a WebAssembly environment. Everything else that we've used has just worked because it relies on the target tuple in order to activate the WASM version of the crate. But get random, for some reason, you have to opt in using this JS feature. Alrighty, so we have our ID. We can now use that ID to actually generate the URL instead of relying on the static string. ID. And I'm going to change this from using the static 22 ID to using the ID variable we created. And it's not a usize, it's a I32 because I said so. Alrighty, we've got randomness. Let's test it out and see how our guessing skills will fare. What is this? This is a leak guy, right? No, that's wrong. This is not a leak guy. It's a far-fetched. Yes, we did it. This is an interesting problem that we're facing now, though. We didn't actually perform any guesses, but every time we hit the Get Pokemon button, our code reassures us that we did in fact guess correctly. Yes, thank you to someone in chat. There is a punctuation. Oh, sorry, what is this? Polywog? It's not a polywog, it's a Pidgeotto. Okay, now everyone in the chat is just trying to guess the Pokemon that I was churning through very quickly. Let's fix these little problems. So we want to yeah, this is a Pidgeotto. This is not a Farfetch'd, but the code is telling us it still is. So let's fix that. Jumping back over to the code. If we think about what we want to do, we actually want to clear out that guess status at the time that the user hits the button. At the time the user hits the Get Pokemon button, we want to do a couple things actually. We want to zero out the guess state, and we also want to zero out the Pokemon that's loaded, because we want to we want the image that's there to disappear for a second. The second part is actually a lot easier. We can run Pokemon state.set none right here from the very beginning of our callback handler, and this is going to make the image and the text box and the guess disappear because there's no Pokemon that's loaded. But we also need to do the same thing for our guess state. And in order to do that, we actually have to move our guess state up a layer, because right now it's being managed from inside of this view Pokemon, this view Pokemon component, but the view Pokemon component has no access to the status of this button being pushed or not. So we need to move this state up a layer. So let us do that. We'll move it out of our view Pokemon component and into our root component. And that's going to cause just all kinds of errors for us, but that's okay. We'll work through those. At the time our onClick handler is called for the first time, we'll call guessState.setNone in order to zero out our guess. Next, we're going to have to pass our guess state back into our view Pokemon. And instead of passing in an option guess, we're actually going to pass in a handle that will allow us to change what's in the guess state.
Recording stopped.
And I believe this error is hitting us because we also need to now be passing guest state into our view Pokemon struct. Use a moved value. Did I create an outer? No. Okay, wow, a lot of stuff in there. Let's jump to the application, and I think we may be pretty much there. We hit our get Pokemon button. It loads in a Pokemon. Oh, this is one I actually do know, of course. Oh, no, I don't. This is an Ivysaur. We hit submit. It says, yes, you did it. It's not, as I initially thought when I saw it, a Squirtle. No, that's wrong. I'll hit get Pokemon again. It zeroes out our guess. It zeroes out the state that says, hey, you did a good job guessing the guess. This is a... Anybody? Dang, I thought Twitch chat was on top of things. Metapod. Alrighty. We got that one. So, yes, Metapod. Thank you, Ian. Yeah, that was basically all of the content that I wanted to cover. So there was so much stuff that we got to in there. Are there any more questions from anybody on the chat or anybody on the voice stream about the stuff that we covered in here? Awesome. Well, thank you to everybody who tuned in to the stream today. I do want to plug my book. Encourage everybody to check out Refactoring to Rust. It's a book about incrementally adding Rust to existing applications to make them faster, safer, and easier to maintain. It is available now in early access at manning.com. Please check it out. It looks like there might be one more question before we break the stream. From the Twitch chat. One of the more nasty things JS does is duck typing. How well does that play with you? That's a great question. So I think it comes down to how well you can isolate JavaScript code from Rust code and how well you can, model these things against each other. Basically, when you're passing objects back and forth between Rust and JavaScript, you need to have some kind of a service boundary because Rust is, of course, extremely well statically and strongly typed, and JavaScript is not. The most common way to pass things back and forth between JavaScript code and Rust code is using JSON. So stringify something on the JavaScript side, parse it on the Rust side, and act on it once it's been parsed. You would commonly do this using something like JSON, or I think that the some of the lower level libraries like WebSys might have some easy wrappers that you can use to make that a little bit easier on yourself. But yeah, basically you would use JSON to pass back simple values between each other, and if you needed to pass back more complex values, like for example, these nodes, like HTML input elements, you need to rely on some binding libraries that knew how to hook into the DOM or the JavaScript event library or something like that. Rust does have some primitive support for casting and, you know, inner outer types. But if you're working with some JavaScript constructs that are like extremely duck typed, where like, you know, every field is optional, or the structure that could be returned from a function varies a lot depending on the arguments that you give it, you might run into some difficulty trying to use that from Rust. That's a good question though. Any final more items before we break? Alrighty, well, thank you so much to everybody who watched the stream today. I had a lot of fun putting it together. I had a lot of fun chatting with everybody. Always love to get questions. So I hope that I can do some more in the future, and I hope that you'll come watch when I do them. Have a great rest of your day, everybody.